Exam 2 covers 6.6, 8.2. 6.6 was the last topic of chapter 6, then the whole chapter 7 except 7.4 or 7.5 was skipped. And then 8.2. Let's start with 6.6 and then move on Friday. Improper integrals. Improper integrals, there are 3 types we gave you. Type 1, the obvious one. It's like from, I don't know, 1 to infinity. Whatever that integral is. Say 1 over x squared plus 5. It is improper. Well, actually, let's do the one I see in front of me, right? Let's do this one. Why create something new if there is an integral in front of me? 0, 1 over 4 plus x squared. This one. It's improper because it has infinity, so it's not a finite number. It's supposed to have limit. It has infinity to it, so you should have some kind of intuition that something is not proper here. That's why it's not proper. So infinity is a troublemaker. Either minus infinity or plus infinity. Second case was not very obvious. 1 over x plus 2, and then we have minus 2 to 5. Then it's not very obvious, but when you think about it, you're like, oh, I cannot divide by 0. So wherever this integral is has division by 0, that's the problem, right? So that's minus 2 is the problem. And the last one is the hidden problem. Oh, in European culture, we're circling the problematic place. In the third type, you have problem hidden even more. It's from, say, minus 10 to 7, 1 over x plus 2. I don't see any problem. What's the problem here? Well, at x minus 2, we divide by 0, and it is somewhere in the interval. And the interval is from minus 10 to 7. Minus 2 is somewhere in the middle, and that is going to be the circle. So we break it into 2 integrals from minus 10 to minus 2, plus minus 2 to 7. And now I can circle each problem. Here it is. 3 types of improper integrals. Yes?
If I'm not mistaken, don't we just replace those with an A or a B or something?
Yes, we're going to do it right now. Good job. Good job for remembering. That was a long time ago. It was exam 1, basically. We just were doing exam 1. That's like the first topic. So it's improper because you cannot just start integrating it and plugging infinity, okay? You use limits. Limits are used when you need to approach something, and we cannot do it without limits. From 0, choose any letter you like. Let's use T for a chance. But you can do anything. D, J, B, A. So in this case, I use a T. T goes to infinity. Now, this integral is treated as a typical definite integral. We're just integrating it without any hassle. Integrating the way we know, using your substitution, integration by parts, whatever we learned. And then at the end, we remember that T is blowing up to infinity. Or minus 2, or minus infinity, or 0, whatever it is. For the second example, same thing. We're going to do limit, integral. Now minus 2 is the problem. So let me put T there. 5, 1 over x plus 2 dx. T now goes to minus 2. And the third example, we have 2 limits. Minus 2 is approached from the right or from the left. To be honest, we're teaching you the difference between from the right and from the left, which can be found like so. From minus 2 to 5, we're approaching it from the right, so it's plus. But calculations will not change. So to be honest, if you forget that, you'll get the right answer anyways. But it's correct. You need to be picky about this to make sure you don't blow up everything when you approach from the left. It just doesn't exist from the left. Questions about this before I go to solve the first one? Do you remember this? I'm going fast because it's review. Put a fat star if you don't remember this, or like put exclamation mark, or put smiley face if you do remember this. Make some notes, reflect on your knowledge, and then you have less than a week to really fast prepare for it. So we're gonna go and try to solve the first one. Limit T goes to infinity, integral from 0 to T. So what do you think we should do with this? What method we should use to solve it? Someone mentioned USAP. You're not wrong, but it's not happening right now. The question for you is, What is the derivative of arctangent? What is derivative of arctangent? 1 over what? 1 plus input squared, x squared. So if x is the input, let's call it u. Arctangent of u, 1 over u squared, and u will be u substitution. In this case, what we have is, check this out. We have 1 over, I'm factoring out 4, 1 plus x squared over 4 dx, right? 1/4 can be kicked out. 1/4, I will kick it out outside completely. Limit integral from 0 to t, 1 over 1 plus x over 2 squared. Those little things supposed to give you the right answer. That is arctangent of x over 2. We use u substitution. This is u. U is x over 2. du is 1/2 dx. Change limits of integration or don't change limits of integration. You decide. You want change?
It would be the same.
Not really. T will be t over 2, but infinity doesn't matter. But sometimes matters. If it's 1 over u, then t will become 1 over t, and it will be different. So it's very interesting, actually. But good point, good point. Let me change to be correct. 0 is still 0. So many people ask me what is happening here. Too many people ask already, so let me show it. When x is 0, u will be 0 over 2, which is 0. When x is t, u will be t over 2. Those are my new limits of integration, a and b. Changing, so 1/4 limit t goes to infinity. Now we have integral from 0 to t over 2, 1 over 1 plus u du, correct? No. What is missing?
And also 2.
Oh, first of all, squared. That's like duh. But 2. 2 is missing. You see this 1/2? I need to multiply it by 2 to isolate dx. So it will be times 2. That is u substitution. You forget what's going on. Review u sub. U sub is so important. You should not pass this class without u sub. U sub, integration by parts, and Taylor series. This is the core of this course. And Taylor series comes in a week. That's like the must. Yes.
Where did we get the x over 2 from?
I chose it to be u.
Right.
So x over 2, I'm choosing this to be u. Let u be x over 2. Right? U sub, you always choose something to be u. Are you blanking out?
It's x squared over 4.
Oh, I see. That's what you're asking. I see. That is x squared over 2 squared. Yeah, that's a good question. Good job. I was wondering what's the question. Yeah. Nice. Good job, people. Anyway, integrating, you get arctangent. So let's do it. We have 2 times, let's multiply 2, and then there's an over 4 limit, and then you have arctangent, and then you have 2t over 2 minus arctangent of 0, arctangent of 0. This is what is happening. I'm skipping one step because it's too much writing. And you should also skip. At some point, you become so good at all of this that you go fast. So, what I was trying to do is to tell you how to calculate arctangents. Check it out. Arctangent of 0 answers the question, tangent of what angle is 0. That's the inverse function idea, the definition. Tangent of what angle is 0. What's the answer? 0. There are more than that, but from minus pi over 2 in pi over 2 is only 1, and arctangent is restricted. So tangent of what angle gives you what? Where does this go? To infinity, because t goes to infinity, right? So in tangent of what angle gives you plus infinity? For that, you need to remember the graph. Calculator might help you if you graph it. Or remember, tangent is a chair. See? It's a chair. That's how I memorize it. It's a chair. It's infinitely growing to plus infinity and to minus infinity. Up and down at minus pi over 2 and pi over 2. Moreover, there are infinitely many of those chairs. The left and to the right. So, but usually we use 1 because we don't have a shift most of the time. So, when does it go up? At pi over 2. This whole thing is pi over 2. So what is the final answer? Pi over 4. Which I told you that. See? I remember it's pi over 4. But don't try to memorize answers like this because, of course, in the test I might multiply everything by 4 at the very outside, and now the answer will be different. So make sure you don't, if I multiply, let's see, if I just, where is it? If I multiply everything by 4, now the answer is pi. So like, make sure you don't just memorize this if I put this in a test. What do you think about this? Make sense? Does it make sense?
Why would it be pi halves and not because it's only pi halves from the negative direction.
Pi halves. So to plus tangent of what angle gives you plus infinity?
But it's not infinity. It's infinity from one side and negative infinity from the other.
I know what you mean. We are talking about going up. Doesn't matter from the left or from the right. But yes, I would say we're restricting it on this domain, like so. So we only look at one chair. Approaching pi over 2 from the left. We're going up forever. Does it make sense? Did it answer?
For all tangent stuff, we just refer to the middle one.
Yes, and actually there's a specific answer why. So the question is why we don't look at other chairs, other tangents. Inverse functions are restricted. Inverse functions are on some kind of restricted domain. Usually, by coincidence, not by coincidence, that's a joke. Minus pi over 2 to pi over 2. That's the way they were created. Inverse functions, original function is infinite, have domain and range. When you try to reverse it, you have restriction on it. So just like x squared can be reversed with a square root, but like x squared has all possible input, square root of x doesn't. So inverse function often has a restricted domain. Same with arcsine, arccosine, arctangent, arcsecant, arccosecant. Good questions, good job. More? Yes? Pi over 4, he's from, I knew someone would ask, good job. I knew someone would ask, how did we get pi over 4? Here, this is 1/2. It's like I skipped it on purpose because I wanted someone to ask. No, good job. I'm pretty sure half of you did not notice why it's pi over 4, but nobody wanted to ask. So I was wondering if someone gonna ask. You see, the brave one, they ask and then clarify everything. This whole class depends on the brave people. How about this one? Can you just tell me what the answer of this integral? Approximately. Bless you. No, I mean the integral without improper stuff. What is integral of 1 over x plus 2 approximately? It's natural log. Good job. Is it approximate or exact? Am I correct or not? Yes. And now you plug 5 and t, right? So you immediately can write it down. Check it out how fast it is. X plus 2, but instead of x, you plug 5 minus x plus 2, but instead of x, you plug t. And now you check what t is doing. T is going to minus 2, and you make decision based on that. So you see, you can actually do it really fast. So now the hard problem is just to figure out what does logarithm is doing at 0. For that, you need to remember the graph of logarithm. Let me write it down nicely, and then we can go. Number 2 will be limit t goes to minus 2. We have natural log x plus 2, so it's 5 plus 2, minus natural log x plus 2, so it's t plus 2. But t goes to minus 2, so the whole input shrinks to 0 from the right. The first is the number, log of 7, that's a number. Everything depends on the second one. The second one, to know the answer, you need to remember the graph again. The graph of the logarithmic function looks like so. At infinity, it goes to infinity, but around 0 from the right, it goes where? Where? Down. Going down, 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 down. Whoa, whoa, whoa. Whoa. I think it's Justin Bieber. No, I don't know. To minus infinity. So everything diverges. We even can know to what? Since this whole thing goes to minus infinity, the answer is plus infinity because minus and minus. Makes sense? So just don't mess up. I mean, that's a very easy thing to say. I just hope you don't mess up. If you actually calculate, don't forget the negative sign. Don't get confused. Don't overthink this too much on the test. And I think that should be good. Just don't forget you have to prepare. It's better to have 20 minutes per day than 8 hours on Sunday. Good job, people.